Section 10.6 is trigonometric ratios. I can find and use trigonometric ratios. Big ideas here. Sine, cosine, and tangent ratios can be used to find the measurements of sides and angles of right triangles. Angles of elevation and depression can be used to solve real-world problems. So here the ratio of the side lengths of a right triangle are called trigonometric ratios or trig ratios. If you look on page 645 in your textbook, we have a take note there. The sine of angle A, or sine A, is the ratio of the length of the leg opposite angle A to the length of the hypotenuse. So if we have a triangle, a right triangle, kind of like this, and we have angle A here. Opposite is this side length. And here we're talking about our side lengths. This is opposite. And our hypotenuse is always opposite our 90 degrees. It's always our slanted side, our longest side. And sine of A is opposite over hypotenuse. We use SO to remember this. Sine equals opposite over hypotenuse. The cosine of angle A is the ratio of the length of the adjacent side. Adjacent is right next to, shares a side with our angle. So here's our adjacent side. It shares a side with our angle. And in cosine, our adjacent is compared to our hypotenuse. So it's the ratio of adjacent over hypotenuse. Here we use ca to remember that. Ca is cosine equals adjacent divided by hypotenuse. And lastly, we have tangent. And tangent is the ratio of the leg opposite to the leg adjacent. So here with tangent, we have tangent of our angle is going to be opposite over adjacent, and we use TOA. So here we have SO, CA, TOA. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and TOA equals opposite over adjacent. So, CA, TOA. You're going to want to memorize that, get that stuck in your noggin, because that's how we remember our trig ratios. So, CA, TOA. In example 1, we're going to find our trig ratios. So, sine of A, cosine of A, and tangent of A for the triangle on 646. I have something kind of similar to it here. So, for angle A, so we're looking at this angle. And remember, our trig ratios have to do with the sides. So from angle A, we have to figure out what is O, what is A, and what is H. O is opposite. Okay? It's like if we shot through that opposite. This is O. It's kind of the odd man out because it doesn't do anything with our angle. Our hypotenuse is always opposite our 90 degrees. It's always our slanted side and our longest side. And our adjacent side is part of our angle. Okay? It connects the 90 degree angle with the angle we're looking for. It's our adjacent side, it's right next to, shares a side with. Okay, so between our triangle and our angle, they have this common side. So now that we've figured out our O, our A, and our H, we can use SO, CA, TOA. And remember, SO means sine of our angle equals opposite over hypotenuse. Here we have opposite is 15 and hypotenuse is 17. So 15 over 17 equals sine of A. CA means cosine of our angle, which here happens to be A, equals A over H. A we said was 8, and H is 17. So 8 over 17 is cosine of angle A. And TOA is tangent of angle A. So SO is S for sine, CA is C for cosine, and TOA is T for tangent. And it's O over A. O here we said is 15. And A we said is 8. So tangent of A equals 15 over 8. So again, so is S equals O over H. Ca is C for cosine equals A over H. And T for tangent equals O over A divided by. So top and then bottom. Numerator, denominator. Numerator, denominator. So here we're going to use the triangle. Feel free to pause and give this a try if you'd like. And we're looking for sine of angle E. So from angle E, I need to figure out what is my O, my A, and my H. O is my side opposite, the one that's not a part of my angle, which here is 9. So that's my opposite. My hypotenuse is my longest side, and my slanty side here. So that's my H for hypotenuse. It's opposite of my 90. And my adjacent is the one that's part of the angle. So not my hypotenuse, but from my 90 degrees to my angle, it's the side that they share right next to, adjacent. So A is 12 and H is 15. Sine is so, which means sine of my angle equals O over H. Sine of E equals O, we said is 9, and H is 15. And I can reduce that 9 over 15 is the same as 3 over 5. So sine of E equals 3 over 5. Cosine is ca. C for cosine, C for ca. Cosine equals A over H. So cosine of my angle E equals my A value, 12, over my H value, 15. And again, reduce here, I can take a 3 out of both of them. So I get 4 over 5 equals cosine of E. Tangent is TOA. So tangent of angle E equals O over A, opposite over adjacent. My opposite is 9, and my adjacent is 12. Again, I can take a 3 out of each of those, and I get 3 over 4 is tangent of angle E. And those are sine, cosine, and tangent for angle E. And again, we pick our angle. So since we're talking about angle E, I go opposite. Adjacent shares the side of my angle, angle and adjacent. And my hypotenuse is always my longest side, always opposite my 90. And we've talked about that before when we did Pythagorean theorem. In example 2, we're going to be finding the trig ratio and finding the value of cosine of 55 degrees to the nearest 10,000th. So a couple things to do here. This we're going to type right in our calculator. So remember though, in our window, like where we see numbers that are typed in, on the bottom, about here, it should say DEG. If it doesn't, if it says RAD, then next to your second key, there's a DRG key. Click this, select degree, and then press enter, or equals. Okay, and then it should have the DEG there. Now, we are going to use the cosine key. And again, these are instructions based off the TI that I have in my room on the wall. If you have something other than the 2-line TI, then it's going to be a little bit different. And if you have trouble with that, let me know. So here, we're just going to press the cosine key, which is 3 columns and 4 down. Okay, it's like 2 above the 8. So we press cosine. It brings up a parenthesis. So we put in 55, close our parentheses, and press enter. And when we do that, I get approximately 0.573576436. Nearest 10,000th, we have 10th, 100th, 1000th, 10,000th. So 4 decimal places. I look at the 7 that follows. 7 rounds up. So here, cosine of 55 degrees is approximately 0.5736. Same idea here. Make sure your calculators are in degrees. And then we're going to use the sine key, which is next to the cosine key, 2 up from 7. And we're just going to press sine, 80, close your parentheses, press equals. Here I get 984880775 and again I'm going to round to 4 decimal places. 1, 2, 3, 4, 0 rounds down, so I get approximately 0.9848, 4 decimal places, or 10,000th. Tangent of 45. Tangent key is on the opposite side of the cosine key by your divide, and there we just get 1. Cosine of 15 again. 965925826. 4 decimal places, 2 rounds down, so approximately 0.9659. And if you're not getting these and need some help typing them in your calculator, let me know. Sine of 9 degrees, approximately 0.156434465. The 3 rounds down, 0.1564. Here we're going to find the missing side length. So we have an angle measure, right triangle here, and we know one of our angles is 48 degrees. So from angle 48, I'm going to figure out if I have O, A's, or H's based off the information that's given. So opposite is where my X lives. This X is opposite. And the 14 is my hypotenuse. It's opposite my 90 degrees. It's my slanted side. It's my longest side. I don't have anything for A, for adjacent here on this side, so I'm just going to not worry about that. I'm going to worry about the trig ratio that deals with O and H. So out of SO, CA, and TOA, since from my angle here I have O and H, I'm going to use sine. So sine of my angle equals O, which we said was X, over H, which we said was 14. And now I'm going to try and solve to get X by itself. X is being divided. We get rid of division with multiplication. So 14 times sine of 48 degrees equals X. When you do this, make sure you close your parentheses here if you're going to put the 14 after, or take 14 times sine of 48. And when we do that, we get approximately 10.4040276. But we're going to round to the nearest tenth, which is 1 decimal place. So the 0 rounds down, and I get about 10.4. Double check, does my answer make sense and seem reasonable? Well, here it should be less than 14 because it's one of our side lengths, and it is, but it's not like 0.2. Seems fairly reasonable. Here again, we're going to round to the nearest tenth, and I know my angle is 35 degrees because that's the one that they give me. So from that angle, I pick out whether I have O's, A's, and H's. I know for sure that X is going to be my hypotenuse because that's my slanted side, my longest side, and opposite my 90 degrees. And then because my 1.575 is part of my angle, it's my adjacent side. So now I'm going to look out of SO, CA, and TOA and figure out which one has A's and H's in it. And that's cosine. So I take cosine of my angle, and that's going to be A 1.575 over HX. To solve here, I have division, so I get rid of it by multiplying. And then I get rid of my multiplication by dividing. So it's not always necessarily going to be the same trig ratio that we use. It really just depends on what values we have. When I type this in, I get 1.922719977, so I round to 1.9, which is longest and our hypotenuse.